Hello, everyone. We are Team Spark for MAE 3230 Fluid Mechanics class. And for our fluid mechanical dissection, we ended up getting an instant coffee maker, which performs two main tasks. One task is to deliver boiled water into the system in order to make the coffee, and the second one is to prevent overflow of the system. And the coffee maker, after removing all the circuitry and plastic parts from the coffee maker, we ended up seeing two pumps and four pipes, which in unison achieve these goals.
Here we can see our overflow safety system. The left image is the container that holds the water that is going to be heated and made into coffee. And these three pipes depicted in the right image are there in case you overfill the system. And instead of flowing on to electronics or other components, the fluid will flow into these three pipes to a waste container at the bottom. And this process can be accurately modeled by the Bernoulli equation. And so the question is, how does the water get to the coffee pot to eventually serve the coffee? From the water container to where the needle is, there are two fluid mechanisms involved, manometer and siphon, where the pressure difference from the water container pushes the water all the way up through a tube that connects to the needle and the coffee pod. Once the fluid gets to a certain height, the system acts as a siphon and the water drops and extracts the coffee out of the pot.
Yeah, so here we can see the system acting as a manometer where it starts at equal pressure, and then when the pressure in the container is increased, you get a difference in height in the fluid. Based on where the top of the fluid line is, we estimate that was about 2 centimeters. So using the hydrostatic equation, we could relate that to the pressure difference that this machine must make, which was about 195 pascals, which is not that much different from atmospheric pressure. And we have to assume that the fluid is not moving to do this analysis. So then once it reaches the top, we could start to see it act as a siphon, which can be described by the Bernoulli equation. Here, the fluid is going to keep flowing out, and using our pressure difference and some assumptions that the velocity in the container is zero, and we can zero the height at the exit, we can find that we need a height difference of negative 2 centimeters. And so this means that the container height can be lower than the spigot exit. We have to assume that the flow is inviscid and incompressible.
Yeah, so the top container becomes pressurized, primarily using this diaphragm pump, as well as this T-shaped junction. So basically, this air is intaked through the rightmost tubing, and then it goes through this one-way valve, and then goes into this high-pressure tubing, which is connected to the top of the container. And the way this one-way valve works is that when pressure is higher on the left side, or the bottom section of it, or the top section rather, that section is closed off and allows only the flow to go in one direction. So it does not allow the high pressure section to escape. And once the system is done emptying, the pressure equalizes and allows all the pressure to escape throughout all the tubing.
So this is one of the pumps found in the coffee machine, and it works very similarly in terms of fluid mechanics to that of a combustion engine, where the piston moves down, increases the volume, therefore decreasing the pressure in the chamber, drawing in the fluid, and then it moves back up to push the fluid out. And it's very similar to the second pump that we found, which is a diaphragm pump. Works in the same way this time. However, it's just the movement is caused in a circular fashion caused by a motor.
And that's it. Thank you, everyone, for watching.
Was that within